Sorry, I'm a few minutes late here. I was transitioning from a different class. So I will kindly ask if one of you can help confirm if you can hear me just fine. The thumbs up or something will suffice. Or you can just unmute yourself or something. Can you hear me?
Yes, you can.
All right, thank you. Thank you so much for confirming that. What I'm going to do is I'm just going to download this and then we can start. It'll take a while, it appears here. It's going to move it. No, ODP sometimes fails. I made some changes here, so I'm just going to have to re-export this something. All right, so I'm not really sure if there are any specific questions that people might have as they relate to the things that we discussed in our most recent interaction. We really haven't. We're barely scratching the surface here. We haven't gotten to a stage where we've actually even started looking at the complex stuff, I guess. But we are looking at the basic fundamentals, really. And so when we met last time, we extended our discussion, our previous discussion, by looking at interesting things like data types, if you remember, the native data types in Python. Quite interesting, actually, that Python has a restricted set of primitive data types, if you will, is it? So broadly be looked at as comprising of numbers and strings, ideally, and also Boolean, right, values, if you will. So with numbers, we realize that numbers are of two types. You have so-called integer values, so these are whole numbers, negative and positive, including 0, obviously. And then also we have floating point numbers, right? Numbers with a decimal point, ideally. And you'll notice from some of the examples we're going to be looking at that what determines what sort of data type you're going to use is contextual. It depends on the type of problem that you're solving. Okay, so if I'm writing a computer program that is going to be processing results by students, then obviously I have to use floating point numbers because a grade can be a 68.5, for instance, or 68.1, and then we looked at strings, okay. We also looked at Boolean values. Now, all the while here, what you want to pay particular attention to, with respect to the different kind of data types what we looked at and the operations, is how you go about defining these data types and what sort of operations you can perform, okay? You cannot perform subtraction on strings. So for instance, you can't say, well, what I'm going to do is I'm going to do this. I'm going to say string CSC 6741 divided by another string CSC 5019. This will not work, right? Because it's something that cannot be performed on a string, right? You can't perform subtraction on a string, you can't use the modulo operator on the string, for instance. But where is it now? Jesus, I don't have it. Oh, there we go. It's here. You can't do that, right? So you want to be wary about the different operations that can be performed. And then we had a discussion of so-called Boolean values. We had a discussion of Boolean values, and with Boolean values, we realized that they can only evaluate to true or false ideally. Okay, that's one thing. So it's either true or false ideally. And then also in terms of operations, we have so-called binary operations rather, and also an unary operator. You know, so there are certain operators that can act on two Boolean values. So true, if you have two values, true, the other value is true, you can perform some sort of operator, right? Which ideally would have to be one that performs a binary operation ideally. Okay. There are some operations which are unary in nature, like the not, for instance, where if you say not followed by the Boolean value, it negates it ideally. Okay, if that makes sense here. Something else that came up, I guess, during our discussion of these Boolean values is that we realize that we can make use of what's called the truth table, right? Where in the event that you're performing a number or chained operations, you can use the truth table to determine the outcome, the predefined outcome. So the simplest one is your unary operator not, you know. So not has, because there are only two values, is it? Boolean values you can ever work with, true or false. True, there's true, and then there's false. So if you're using the not operator, not true is false, and then not false is true, ideally. But when you're working on these binary operators like and, which is conjugation, and or which is disjunction, conjunction and disjunction, we notice that the behavior is slightly different, is it? With and, because you have two values, right? And requires two values. There are different combinations that you can have. First combination is where both values are true, so true and true will give you true. The other configuration is where the first value is false and the second value is true. So false and true gives you false. The other configuration is where the first one is true, the second one is false. So true and false gives you false. And then the last one is one where both are false. False and false gives you false. So in other words, when you're looking at conjunction, the value will only be true when both values are true. And then when we look at disjunction, really, we're using the or operator. It's like the value will only be true if at least one value is true. Okay? So true or true gives you true because at least one value is true, both are true. False or true gives you true because one of the values, the second one is true. True or false gives you true because the first one is true. False or false gives you false because both are false. So you notice really with disjunction that the value is always going to be true except in instances where both values are false. It's pretty straightforward. And it turns out that this is all you need to know and understand for you to be able to perform what we again discussed, which is condition operations, is it? When we're making decisions using if statements. There are instances where, because an if statement expects a Boolean expression, if something, that something must evaluate to true or false. And if it's true, then it's going to execute the code that follows it or something like that. What we discovered with decisions is that there are instances where you only have two alternatives, right? The case where it's true and the case where it's is false. In that instance, the code construct to use is an if-else statement. So you would have something like if, and then Boolean expression, full colon, you execute if true, and then you have else, execute if false. Okay. And then you have instances where you may need multiple conditions, is it? If this, then do this. If Boolean expression, then execute. Then you can have elif, Boolean expression, true, we execute. And you can have an unlimited number of conditions here. And then at the end, you can have an else here. Is it? Execute if true. It is also possible for you to just have one if condition if you want. Now, if you want, you can also have a case where you have, imagine that example we had, where we are saying we will have the VASCO is equal to 56. And we want to check here if VASCO, one option would be if VASCO is greater than or equal to 50, then print pass. And then you could say else print false, fail. But it turns out that you can come up with an implementation of this where you say if VASCO is greater or equal to 50, then print pass. And then you can again have an if condition here. If VASCO is less than 50, then you say print fail. They'll work, right? We know that this should print pass, so it will print pass. It's called construct. And I want to add this here as well, so that it's the same. If we copy this code construct here and just paste it in our terminal, print pass, right? This is a modified version. It's the same thing. Logic is the same, but we just have two if conditions. It will print pass as well. I don't know why it's fading here. No. I don't know why this is fading here. Right, so you can have two separate if constructs ideally following each other, and they'll work as well. So if I were to change this to 40, right, assuming these are in the same thing here, I'll run this first, I'll check. It won't print anything, and then when I copy this and print it out, it will tell me that it's a fail, right? If this makes sense. Anyways, and then we looked at loops, so how to write for loops and also while loops, which was pretty straightforward. So today we want to transition and briefly talk about functions, right? So before we have a dedicated discussion of data structures, because it turns out that our discussion of data structures is also going to require that we look at inbuilt functions. We'll first of all discuss inbuilt functions and then also look at how we work with modules as well, ideally. So in terms of function, it turns out that the function is defined as a reusable block of code that is aimed at performing a specific task. Okay? So imagine a situation where you're writing a computer program and you want to perform a task, right, over and over again. the best thing for you to do is you encapsulate it into what's called a function. So you create a code block that's called a function. So the benefit of using a function is the function will prevent you from performing repetitive operations, right? So you only write code once, and then every time you want to execute the same piece of code, you're just calling the function or you're invoking the function. And then from an aesthetic point of view, what functions do is they help you organize code. Okay, so people will be able to easily follow what it is you're trying to do ideally. Functions also improve code readability. Okay, so as people are, imagine a situation where you're writing very complex code, like here. I think I've used this as an example. I'll go into pandas. Excuse me. Let's say I want to open up one of these internals. You notice that this is not very complex. It's a complex it's a complex modifier, right? The idea behind this, or maybe we should just open up core or something like that. And then we just go to series or something like that. The idea behind functions is you have this complex modifier with 8,771 lines of code right here. Quite complex here. And it turns out that it makes life a lot easier for you to be able to define functions, right? To be able to define functions. If I can find to define functions. I want to be able to define functions so that at some point in this 8,771 lines of code where you want to run a repetitive piece of code that you'd have already run before, what you just do is you just evoke it. Right? So you just say D types and then you evoke it and then you'll be able to use it like that. And then it turns out that when you're using functions, it's a lot easier for you to find problems with your code. So the process of finding problems with your code is referred to as debugging. So it's a lot easier for you to debug because you can easily trace where exactly that error is coming from. Imagine there's a problem with this module file 8,771. If you just write, if you're writing repetitive code over and over again, it's difficult to trace where the problem is coming from. You'll be able to find the source of the problem, but it's a lot easier when you decouple code like that. So I have an example here, right? Let's say you have a recipe for making coffee, a function about a recipe for making coffee. Once you have that recipe, what you can do is you can just reuse it, is it? If it's somewhere in your kitchen, you go and pick it up and then you're following it through. If somebody else is preparing coffee, you just give them the recipe and then, they'll be able to replicate what process they have to go through to make the coffee itself. So whenever you want to make coffee, instead of writing the steps, you are using that recipe idea. The idea is the same with functions. Okay, but what's important for us is to appreciate how exactly we go about creating a function. In Python, it turns out that a typical function in any type of programming language will have a body and what's called a signature, right? In Python, what you do is you create functions by using the define keyword, def. If you remember, def is one of the reserved words in Python. So you cannot use them as variable names. You can't use def as a variable name. Okay, if you do, it fails, is it? If you come here and you say, I want to create a variable def to be equal to a string CSC6741, this will fail. It's an error because def is a keyword here, def. So the syntax is simple. You begin a function by specifying the def keyword, space, and then you specify the name of the function. You are the one who has got to specify the name of the function. It can be any name as long as it conforms to those rules for creating identifiers, if you remember. After the name of the function, you have an opening parenthesis, right? And a closing parenthesis. Inside the parentheses, inside the open and close parentheses, you can have an optional list of comma-separated parameters. The list of comma-separated parameters must conform to the rules of naming the identifiers. They are optional because it turns out that there are functions that will not require a parameter. You just run them as is. Okay? After the closing parenthesis, you have a full colon. The full colon is what ends the method signature or the function signature ideally. After the full colon, you specify the body of the function. Okay? And when you're specifying the body of the function, it has got to be anything that goes into the body of the function has got to be indented to the right to tell Python to say the things that follow are supposed to be part of the defined function. Now, in the body itself, you can optionally use the return keyword. In the case where the function returns something, or if there's no return keyword, the function won't return anything. It's like a void function. So you begin to notice here, right, that what we've specified as a syntax conforming to a function will at most use, well, as part of the definition, it will use two keywords, the def keyword and the return keyword. Again, if you go here, you'll find that return is a keyword. Because return is a keyword, I can't say return is equal to CSC 6741. This is a syntax error. However, if I use return with uppercase R, it will work. Why is that? Because Python is case sensitive. So as far as Python is concerned, this return is different from this return because the keyword return is all lowercase. Okay, so what I'm showcasing here is syntax for defining a function. We start off with the def reserved keyword space, followed by the name of the function. In this particular case, the name of the function is fxn underbar function underbar name, open parentheses, close parentheses. This function has two parameters. They are comma separated. Is var underbar parameter 1 and var underbar parameter 2. Full colon, right? What follows this after the full colon is the body. So it has got to be indented. Incidentally, in this particular example, it's a horrible example, but we start off with the doc strings, is it? If you notice, this is a comment. Triple quotes, triple double quotes, triple double quotes, closing. Open triple quotes, open triple double quotes, close triple double quotes. This is a doc string. The interpreter will ignore this when it sees it. And then afterwards, you have the method body. And then in this particular case, we have the return. More on the return keyword later here. Right, so I'm just showcasing the syntax in this particular case, but in here I'm showcasing an example of a function that has been given the name fxn underbar greet. Right, so notice we're defining it by beginning with def space, name of the function, and then this function takes in one parameter. The name of the parameter is var underbar name, full colon, we have a doc string, and then what we are doing here is we are saying we want this function to just print the word hello, comma, followed by the name of whatever thing is passed in the function. Incidentally, when you're defining a function, what goes into the parentheses is called a parameter. When you're calling it, evoking it, when you want to use it, the thing that goes in the parentheses is called an argument. Okay? So we define a function. For us to use the function, we evoke it or we call it. And the way that we evoke it or we call it is we use the name, open parentheses, close parentheses, and then inside the parentheses, we can give it an optional list of arguments that match what has been defined here. In this particular case is one parameter. So we're expecting one parameter here. Okay, so we can invoke this function to see how it works. I mean, we can run it. Uh, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. def keyword space, the name of the function, open parentheses, argument, one argument. I'll run this function. Run. When I run this function, I can invoke it, is it? Now, you see, if I look at the parameter itself, it's difficult for me to know exactly how I should evoke the function. Very difficult, actually, right? Unless if I read the function. If I'm the one who implemented, like in this particular case, I know that at some point in the body here, I'm using the inbuilt function print, and I'm printing the string hello followed by comma, followed by whatever I pass in here. So what I pass in here is something that should be able to be combined, right, with the print inbuilt function. So something like a string. So I can come here and just say, I want to say CSC 6741, so that this will print hello CSC 6741, right? Or because I myself know how the print function works, I can pass it an integer. Okay, it says hello 2026. Because I know how the print function works, I can pass it a list, right? If that makes sense. In an ideal case, by the way, you will be able to read the docstring of the function. You have seen me use the thing print. Like I said, well, print 2026. It will print string CSC 6741. It will print, right? I know this because if I check the definition of this function in the help, it tells me that for me to use a print function, I can give it an unlimited list of arguments, right? Comma separated arguments, right? And then what it does is it has these keyworded parameters here, as already defined here with default value. And then it will print the values to a stream, right? Onto the screen in this particular case. And then they're telling me what SEP is, it's a separator. I can do a whole bunch of things here, right? It's a separator and all those things. So for instance, I could say, oh, if it's this, and I can say 2026, and then I can also have CSC 6741, right? I can also have 2028 after 2 years. If I print this, it will just print a comma separated list of these things. Because I know the definition, I can tell it to say, oh, I want the separator here to be different. I want it to be this. And then it will do this. There's a hand up.
Yes, Doc. So I wanted to understand at what point do we use the return? In this case, we are using the print, but what about the return?
Well, you use a return statement. I was going to come to that. You use a return statement when you want the function to return something, a value that, and typically it's in instances where the thing that you're returning should be used as input elsewhere. Okay, so I'll give you an example of let's say I want to create a function that will tell me whether somebody has passed. I'll call it grade status or something like that. I'll define this with a score value. Because maybe I want to use this in such a way that it prints, I want to use it in such a way that I'll print something like Lighton has passed or something like that. I will say if var score is greater than or equal to 50, var status. If var score is greater or equal to 50, var status is equal to pass. Else, var status is equal to fail. Now, if I want at this point, I can say print var status. This will work, right? So that if I check var grade status, check the status of 40, say fail, right? Check the status of 100, it will say pass. But you see, what if I want to be able to print this in such a way that print Lighton passed or something like that? I want to check the grade, Lighton at the grade of 40. I want to print this. It will print none here. You know why it's printed none? Because I'm not returning a value here. I'm just printing, right? But if I redefine this in such a way that I say, I'm going to define var status 2. I'll do the same thing here. Var status is pass. Var status is fail. What I'll do here is I'll just say return var status. So in this particular case now, right? If I say print this, but I use var status 1, it will be able to, it will be able to tell me that Lighton fail or something, because I'm returning a value. Okay, so there are instances where you want to return a value, and it turns out that most functions will return a value, right? There's a function I've been using, the built-in function type. If I say type and I give it anything like an int, it will tell me this is an int. It's returning a type, right? If that makes sense. Print does not return a value. Doesn't. I can say print 5, just prints. There's no value returned here. And how I know is I will check the type of this. If it says none, then there's no value returned. Look at this, my function, my two functions is grade status 40. I'll check the type here. What is the type returned here? None, right? There's no value returned. How about the second one I created? It's a string. You understand? So there are instances where you may want to return a value, I guess, or something like that.
Okay, Doc. Thank you.
Yeah, and so this is showcasing. This is a case where I'm just printing. I'm not returning a value. In this particular case, I'm returning something. Is it? right? You use the return keyword to specify what you want the function to return. I've defined a very simple program that adds two numbers. def space, the name of the function is fxn_add. And then it takes two parameters. These are comma separated, var_a, comma var_b. Docstring, and then I'm just telling this function to say, return the result of adding whatever is here plus whatever is here, right? And then in this particular example, I'm saying return what is the value of adding 5 and 3. I'm again assigning the result of this to this variable var_sum because I know that this is going to return something, right? And then I print var_sum. Okay. Yeah, you want to be careful with these functions, right? I'll give you an example here. It's like if we get this function, I don't know if we're supposed to look at exception handling, but this function here. Well, it's like, what happens if I say I want to add, if I want to add 2 and 3, it's 5, right? What if I want to, if I want to see what is the result if I add 2 and the string CSC 6741? This will be an error, right? Because my definition of the function is expecting me to add things, numbers, ideally. So because I'm passing it a number and a string, it fails, right? However, look at this. If I say I want to add CSC 5019 and 6741, this will return the concatenated string, is it? Because we know that we concatenate strings using a plus sign, and by my function definition is essentially just returning whatever I pass it here plus whatever I pass it here. Okay. Hope this is making sense here. Okay, so just the thing about parameters and arguments. When you are defining your function, the things that are listed in parentheses within the opening and closing parentheses are called parameters. Whereas the things that you specify when you're invoking or calling a function would be called arguments because they're actual instantiations, right? The things representing those placeholders. In other words, parameters are placeholders because you know that at some point in the future, somebody will specify a value, it could be a different value. So you have a placeholder called a parameter. And then the actual value that is specified when you're calling a function would be the it will be the argument ideally. Okay, so in this particular example, I'm defining a function that multiplies two numbers. Okay, so function definition def space fx multiply. Then it takes in two parameters var_x, comma var_y. It returns var_x multiplied by var_y. If you look at this result, yeah, var_x and var_y are what we are calling parameters. 4 and 5 are arguments. 4 and 5 is an argument. For some functions, the order of these parameters matters. It depends on the implementation. It matters. Like for instance, if I'm printing, if I want to print the courses I'm enrolled into, beginning with those that are in first semester, if I use the print, I would say I want to print CSC 6741 followed by CSC 5019. The way print is implemented is it will print this first, followed by this. So the order matters. Okay. And then there was a question on return values, or the return itself. What you're doing when you use the return keyword is you're sending a value back to the entity that invoked it as well, and you're stopping the function. So you send the value back and you stop the function. So in other words, what you do when you evoke, when you define a function that has a return statement in it, when it's evoked, it will return a value and then it will stop. Okay? Whereas if there's no return value specified, what is returned is a type called none. This is the reason why for the function like print, if I say type print, it tells me that if I want to print 4, even though I am printing 4 here, the type is non-type, because the definition of the function does not return a value. Okay. So I have an example here. It says the function does the same thing. In this particular case, I'm returning the value of getting the square of a number given here. Whereas in the second case here, it's the same implementation, but I'm just printing it out. The result is the same, right? Observe. From a user's point of view, what is return, what I see on the console is the same, but the difference is in how I can use these things here. So I'll run this, and then I'll also run this. If I say I want to get the square of 10, which is 100, if I run the first one, which returns, it returns 100, right? Observe, if I run this fx print square, it will still, I will still see 100 here. But if I check the type of this is int. If I check the type of this is non-type. So if I wanted to, if I wanted to use the result of the square of a number, for instance, for whatever reason, it would be difficult for me to use this because the return is non-type. So typically when you want to reuse something that is returned by a function, you create a new variable, right? In this particular case, you say new variable 1 is going to be equal to this. Let's say I'm trying to add 1 to the square of a number. It's a random example here. I want to add 1 to the square of a number. I have these two implementations, yeah? var new variable, and then I'll have new variable 2 is equal to this. If I want to add 1 here, I'll say I want to add 1 to the square of 10 so that I get 101. I'll get 101. But if I use variable 2 here, and I say I want to add 1 here, right? It will fail because what is returned here is none type. There's nothing returned, in other words. Okay. Hopefully this is making sense. I'm just showcasing this, right, where you're returning the values and stuff. What you begin to notice is that I've already said we're going to discuss built-in functions, but I use a lot. I use built-in functions like type and print a lot. If you noticed, right? I've been using these often. They're functions. They're built-in functions. More on these later on. There's this notion of scope, right? So in what portion of code, what segment of code are these functions accessible ideally? So we're looking at variable scope here relative to a function. A local variable, one that is defined inside the function, is only going to be accessible inside that function. Okay, so when you're writing a program, a complex program, and you decide to, let's say, define var A, var B, This is fxn addition, and you say var result is equal to var a plus var underbar b, and then you say return var underbar result. If I run this function, right, with let's say 5 and 6, it will return 11 here. But you see, if I attempt to access var result here, I know that when I've evoked the function here, it has obviously computed the result of var result, is it? It has added these numbers 5 and 6. So the intuition would be, if I try to print var result, I should be able to see the result, which is 11. But guess what? You will not be able to see this because this is only accessible within the function itself. It's a local variable, it's local to the function. But if I said var result outside, maybe is equal to 0. I don't know if you'll be able to change it here. And then I come to the function addition. Yeah, which is fine, really. I don't know if this will be able to work here. Addition 5 and 6, and then I try to print var result. It's still 0 anyway. So even the changes to the function are still within the function block idea. Okay. Yeah, I'm surprised that this global function. Oh, maybe when I define, no, I should have, it will only work here if I don't know why. If I say var is equal to 0, and then I define this, it will work. I was getting confused there. I think it should be able to work. Five, 6, print var result. It's still 0. I have to check exactly how these global functions work in Python. Don't know why this is failing. It's supposed to work, this thing here. There's going to be a way of accessing yeah, probably let me see here. It's probably a way of defining a global function in Python. There's going to be a way of defining a global function. Oh, it's a global keyword, so I have to use a global keyword, right? So I needed to do this. Is it var this, and then I would say something like this, and I would say global this, and then I would say this, and then I would say return var result. So that when I evoke this fxn addition, the same 5 and 6, if now I check the var result, it will be 11. So you have to use the global keyword idea. Okay. But they're very. Personally, I rarely use. I've rarely found myself, explicitly using the global keyword, right? I guess it depends on one's implementation, because it can be confusing. It results in very confusing behavior. Yeah. Okay. So what's important is to appreciate that the scope of a variable within a function is within that particular function. You can't use it outside. If you're wanting to use or to manipulate something that is outside of the body of the function, you've got to use the global keyword, ideally. Okay. Anyway, so I have this particular example here, right? Where we can read the global function in this particular case. We can read it here, but we are creating a new local variable, even though we are using the same name here. So what you're modifying, if you look at this, right? What you'd be doing here is you'd not be accessing this here if you wanted to modify it, right? Because it turns out that what is within here is accessible within the body of the function, ideally. If that makes sense. Okay, and so in this particular example, if I wanted to print var local, this would fail because local is only visible within the body of this function, right? And then in this particular case, if I wanted to, I don't know if it's making sense. So in this example, we define a variable var underbar global, which is 10, and then we define a function fxn test. Within the function, we define a local variable 5. This function is defined in such a way that it must print var underbar global. In here, we have access to this global variable 10, so we'll print 10 if we evoke the function. But if we modify, if we change the body here and say var underbar global is equal to 20, we'll not be able to see 20 when we evoke the function, right? Because what is going to be accessible outside of this function is this value 10. Observe. It's a good example, I guess. I'm going to copy this. We have a global variable, var global 10. We define a function, fxn test. And then what we're going to do here is we are going to define another variable, global, give it the value of 20 here. I'll remove this comment here. What we are saying is, in fact, before I add this, I'm going to remove this here. What we're saying is, if we run this code, if we attempt to, I don't know what it prints global. We're supposed to print global here after var. We're going to print global here. Here. I'm going to redefine this. Observe. We've defined a function fxn underbar test. What the function does is, first, it defines a local a variable var underbar local, which is local to this function, which is equal to 5 here. And then in here, we are saying we want to print var global. Okay? And then we change the value of var global to be equal to 20. Now, when we print, it's almost like when we define this function, right? It's going to do a couple of things here. It's first of all going to assign the variable var underbar local to be 5, and then it will print the value of var global. The expectation is that the var global is going to be 10. So what we're going to see is, when we evoke the function, is we'll see 10. After it prints 10, there's something else it does. Is it assigns the value var global to 20. The expectation is that if we print var underbar global, the value should then be 20. But guess what? What we're saying is it will not be, look at this. If we evoke the function test, what we do, it will print, it will execute this code here, these 3 lines of code, assign the value var underbar local to be equal to 5, and then it will then print var global, which will be 10, and then it will assign the value of var global to be equal to 20. So var global will be equal to 20. But if we evoke this, it will only print 10, right? And again, you know, we are, this is the insane here. There's a bit of an error because we're defining the same value here, unless if we had used globe or something like that. I'm gonna comment this out, I guess. Right? So Princeton. So the idea here is if we somehow were attempting to access, if we wanted to access this value here, because this is only local to this function, the idea here, what I was trying to illustrate is that the value would still be able to print is going to be equal to 10. Because what is in here is only localized, right? It's only accessible within here. Whatever changes we're making, they're only accessible here. Ideally, if that makes sense. I don't know if I'm making sense here, but maybe if to avoid that error, right, what I'm going to do is I'm going to copy this and do that. Hopefully this will work. Let's see. I've just changed I've defined the function here, and then I have test, right? So I have 20 here. So I'm printing the value 20, because what this function does is it does 3 things, a refined version of the function. It assigns the value 5 to var underbar local. It then changes the value, or it assigns the variable var underbar global to be equal to 20, and then it prints var underbar global. So at this point, right, we expect that var underbar global should be 10. But guess what? If I print var underbar global, I have 10 here. It's like, how? Because var underbar global equal to 20 here is only accessible within this function, the body of the function. Okay. And then if I access, the other example I have here is if I attempt to access var underbar local, I'll get an error because var underbar local is only accessible within the function. Outside the function, I've defined it within the function, it's there. Outside of the function, it doesn't exist. In fact, a nice way of doing this is I'll print something like var global is that. And then I also print var local, so that you see I've changed the body of the function again. I'll run it. If I execute var underbar test here, it will show me to say var local is 5 because it was defined as 5 within the function. Var global is 20. But guess what? If I check var global, it will be 10 because it's using this that was defined outside of the function. Outside of the function, it's 10. When the function executes, it becomes 20. If it's accessed outside of the function, whatever is happening here is localized within the function, so it will still be 10. If I check var underbar local, even though in the function here it's telling me it's a 5, it will be an error because it doesn't exist outside of the body of the function. If that makes sense. Okay, scope. So this brings us to our discussion of inbuilt functions, and we can continue with that. Inbuilt functions, right? It turns out that the Python programming language provides you with a number of inbuilt functions. So these are functions that exist, they come bundled with interpreter, right? When you install the Python interpreter. Okay. These sometimes will be utility tools. In some instances, they're actually functions that are associated with data structures that we're going to be discussing tomorrow when we meet. Okay, so off the bat here, if you import built-ins, there's a module called built-ins, and you use the dir function, built-in function, to check what is in built-ins. You'll notice that it tells you the functions that are built in, right? Type, I've been using type. There are things like str, range. I've showed you how to use range when you're looping. Yeah, if you remember, I said when you're looping, you can loop within a range, right? For var I in range, I want to loop from 0 to 4. Right? Range is an inbuilt function, right? There are things like some things I haven't used, like ask. I have no idea what this is. Things like open that will allow you to open a file, for instance. I can come here and do something like this. Open in read-only mode, I guess. It's fading here because it's in playground or something like that. Horrible stuff. Right? So I can use the open built-in function to read a file. Okay, so yeah. Open, there's a whole slew of things here. Things like you've seen me use print. This, right? It's a built-in function. That's why I'm able to use it, right? So there are a number of built-in functions. The point I'm trying to put across, right? So some commonly used built-in functions would be for input-output. Is like print, for instance, right? I don't know if there are examples here. Yeah. So some common functions here. There are input-output functions. I should have included input here as well. There are functions that will allow you to convert between different types. Remember, when we were looking at data types, we said if you have an integer 5, you can convert this to a float by using the float built-in. You just feed it 5, it will return 5.0. If I have 5.2 or 5. I don't know, 5.2, and I want to convert this to an int, it returns 5. It chops off the decimal point. Okay, it's a built-in function. So for type conversion. Okay. You see me use the list, tuple, dict, and set functions to create a new list. So for instance, I can say I want to create new list. And what is this new list? It's an empty list using the list function. If I check the type, if I render this list here, show me an empty list. If I check the type, it's a list. Right? So there are some built-in functions that are used to get information. Right, like type, I've used type, len ID, built-in functions for aggregation, right, where you can sum things, you can get the maximum, minimum, or sorted. There are functions that allow you to perform iterations, like range, or enumerate, or zip, map, filter. You see us using this when we look at data structures tomorrow, right? And then there are built-in functions that will allow you to create specific types of data structures, okay? Now, what you begin to notice is that you can use, like when it comes to data structures, the same type of functions can be used to create new data structures, but also to do type conversions, right? Like for instance, if I have a var set 1, 2, 3, 4, the type here is a set, but I don't want to use a set, right? Because I don't want to work with sets. Rather, I want to use a list. What I can do is I can say var list is equal to set, and then var list is equal to list, and then var set. So I'm feeding this list inbuilt function with a set that I've created this to convert it into a list. Right? If this makes sense. So in terms of like some common examples here, I'm just going to showcase print, type, and len, right? Pretty straightforward. Given a variable that is a list with 4 elements, 85, 92, 78, and 88, assuming these are scores, I can check the total number of items I have in here using the len built-in function. So len score gives me 4, 1, 2, 3, 4. Max, if I feed it an iterable function, it show me the maximum value amongst these. Right? So you notice already I can use built-in functions to write an interesting program that will be processing scores. I want to check the maximum value out of all the scores for this course, the minimum value, right? What is the sum and all those things? Okay, so pretty straightforward things here. The thing is, you want to practice some of these commonly used functions, built-in functions. We'll be using them over and over again, like print, for instance, type, and stuff. Sorted, for instance, remember I mentioned here, things like sorted will be used for aggregation, is it? So sorted will return a new sorted list, right? Given a list, let's say it's not sorted. If you sort it, if you use the sorted built-in function, it's going to return the value sorted. By default, it's incremental. It's sorted in increasing order. Observe. I want to copy this. Maybe we can run this, right? Len var_score will return. var_scores will return. Observe. What is this? Or is a type built-in function? This is the list, okay? If I use the len built-in function under var underbar scores, it returns the number of things 1, 2, 3, 4. Max, it will show me the maximum value, which is 92. 92 is the largest. Minimum, the smallest. Sum, it will add up everything in there. Now, if you wanted the average in this particular case, there's no average, right? Yeah, but what about average items? There's no average here, right? AVG or average is not there, right? There's nothing like average here. There's no average built-in function. But what you can do is you can say, I can get the sum and then check the number of items that are in var_score scores. Is it because average is equal to sum over the number of items? So average is at 5.75, ideally, right? And then what we're saying here is that for sorted, notice how var_scores is not sorted, is it? I have 85, 92, 78, 88, right? Maybe I have a unique implementation where I want these things to be sorted or something like that. Sorted returns a list that is sorted in 78, 85, 88, 92. Okay, if that is making sense. And then you have these built-in functions that will allow you to convert amongst these different values. So I can convert this list here, var_scores. Notice how it's a list with square brackets. We haven't discussed this, but this is a list. I can convert this. I can check the type also. It's a list. I can convert this into a set by using the set built-in function. And now it has braces here. If I check this, I can change this, right? It's a set, right? Because I've converted what was previously a list into a set. I can convert this into a tuple. How do I do this? I get this, which is a list, and I'll say I want to convert this into a tuple because the tuple is a built-in function. It's a tuple, parentheses. I can even check the type here and it will show me that the type is a tuple. If this is making sense, colleagues, don't know, maybe not, right? So quite a number of built-in functions. Range, I already made mention of range. When we had class last time, I said on Friday, range can be used in such a way that by default, it accepts 1, and this is the thing. When I was using things like range 5, we didn't know what 5 was. Now we know that 5 is an argument, is it? So the way it works is that argument specifies how many times the length, ideally, How many times are going to loop through this? Beginning 0. So meaning that in this particular case, I can loop var I in here 5 times beginning 0. Var I 1, 2, 3, 4, 5. I can use a different sort of range where I want to loop beginning from 0 to 25, but I want to loop from 0 to 25, but I'll be stepping after 5 units. So it's like I want to loop from 0, 5, 10, 15, 20, all the way, right? What is important here is to appreciate the fact that range is a built-in function, right? Because it's a built-in function, when I invoke it like this, 0, 25, and 5 are arguments. Range is a built-in function. 5 is an argument. Anyway, quite a number of things. There's enumerate, you see it in action, and zip, right? I'm going to defer the discussion of enumerate here, but what enumerate does is best done by showcasing. We'll discuss this when we look at dictionaries, ideally. Dictionaries, ideally. Right, so it allows you to, in this particular case, Alice, Bob, and Charlie are defined defined as part of the list, right? But what I want to do here is I want to assign unique numbers to these different items. So what I've done is, let's say, I want to just use the enumerate function. So in other words, I'm going to enumerate, I'm assigning numbers ideally, right, to what is in this variable, which is a set in this particular case. Okay, there are instances where you may have two, let's say two lists, for instance, right? Two separate lists, but associated with the same data set, for instance. You can zip or combine them somehow, right? So you zip them like this using the zip inbuilt function. I've defined a list with var names and another list with scores. What I want to do is, I would like to, it's like I'm combining, yeah? I'm combining, as I'm looping here, I'm combining, I'm looping through the two different lists when looked at together holistically, if you will. So I'm associating these names to the scores because I know that 85 is assigned to Alice, 92 is assigned to Bob, and 78 is assigned to Charlie, for instance. So I can use the zip built-in function. Okay? When I zip them, what I'm essentially doing is I'm saying every time I'm looping, I can assign, I'm assigning, as I'm looping, I'm looping through these two different lists at the same time. When I'm looping through var names, I'm also looping through var scores at the same time. So I can use the positions, the same positions to be able to print out things like print, name, followed by, I'll just say this. I want you to print name and score as I'm looping through like this. It's pretty straightforward. I don't know. Yeah, so there are more functions, you know, like when you are working with list comprehensions, which we're going to be looking at after our discussion of data structures. You see us use the map function, for instance, which will allow you to essentially apply a function to each element, to an iterable element. So like, for instance, if let's say I want to I'm defining anonymous functions here. Observe, let's say I want to create a function df I think I have grade status, right? I have grade status, is it? So what I can do is I can say I want to use the map function and I want to use grade status and apply it to var underbar scores, right? Is it? So that I guess I can probably loop through this, right? For var I in here, print var I, right? So what this thing is doing is I'm using the inbuilt map function to check which of these score are passes and fails or something like that. If that makes sense, I'm just iterating through this, right? Is it? Typically you'd use this as part of like some anonymous function, right? Using a lambda function in this particular case. Is weird here. I'm looking through this 4 times here. So what I'm going to do is I have this. If this is iterable, then I can convert this into a list, right? Like this. And I think the reason why this thing is, guys, this thing is, I've forgotten how we defined, what is this? Grade status. This is bad. If grade status 45, oh, it's non-type. I should have used grade status 1, is it? Or 2. 2 is better. So I can do something like this. Oh, come on. I can do something like this. Grade status 2, not the 1 was not returning anything. This will work ideally, right? Pass, right? The one we had defined before here had print statements, not a return type. I'm glad I'm using this actually because this showcases the differences between a function defined which returns a value and one which doesn't. Is it? Returns a value, doesn't. Okay? The behavior is unexpected sometimes. And then you can also, use the filter built-in function, right? Where you keep, if a function returns true, you'd be keeping things that would conform, right? So I could say, but I don't know as well. These are var underbar scores, right? I've forgotten I want to leave us with this. I hope this will work. A plus is above 86. So I will just check here, right? I want to check which ones are A pluses, I guess, or which ones are distinctions. So if a grade is above 75, it's a distinction, right? So I'll create another function here, is distinction, distinct, which takes in a score, var score, df takes in var score, and then I'll say if var score is greater or equal to 75, then I will say return true, else return false, right? So that when I have something like this distinction and I say this is a 4, this is false. So what can I do with this? I can use filter, is it? And I want to return only grades, right? Only grades that are a distinction. I'll have to use the function that is this function which returns true or false, and then I'm giving it the scores. So what it has returned here is, and I can miss it. What it has returned is What is this now? It's supposed to. Oh, yeah. It has returned all the three, is it? Because it has left out, but all of them are, that's a problem here. All of these are, I think, distinctions. What I can do is I can change this to is A plus, A plus. And then I'm going to say if the score is greater than 86, 86 is true, else false. So that if I run the function again here, filter is A plus, it will only return, oh, nothing is an A plus, which is beautiful, right? All of these, 85 is not an A plus, but 92 is an A plus. I don't know why that failed. VAR scores. I have a sneaking suspicion this works in such a way that these things are supposed to be sorted, I think. So I suspect. Sorted. No, I don't know why it's not working here. I'm not sure why it's not working. I can look at it later on. I'm not sure why it's working. But the idea behind the filter is that it takes in an iterable object, and then it only keeps elements for which the function returns true, right? So in this particular case, we expect 92 to be greater than 86, ideally. That's weird. Yes.
Yes. Could it be because you left out the return keyword?
No. So I have the return keyword. If you notice in the function definition up on top here.
No, the second
yes. Yeah. It is true actually. Here. Thank you very much. I don't know why it worked here, right? It's like true, false. Thank you. Yes. We're in a hurry here. In here. Thank you very much. So this is return true. And then this, I don't know why it worked without that. So if I run it now, it only return one item right here. 92. Thank you. Beautiful stuff. At least a lot of people, some people are following anyway. So the key thing here is the number of built-in functions. You know, some of them you see us using them, especially when we start our discussion of part 2, which are data structures tomorrow. And in fact, we'll use them extensively as we start going through specific types of modules that we are supposed to go through in the course, right? Beginning NumPy and then followed by pandas, matplotlib, you know, and scikit-learn, I guess. Are there any thoughts or questions? There's a thing about live demo sometimes. Okay, so I guess if there are no questions, again, I do encourage you to, I strongly suggest that you want to practice this. Otherwise, especially if you're doing this for the first time, otherwise the things that we're going to be doing will likely go over your head here. There's a question from Aaron. Yes.
Yes, Doc. Are you able to share a lot of questions? Just questions for us to just kind of practice around functions, you know?
Yeah, so what I've been doing is I don't know if you want me to explicitly do this. Yeah. So
yeah, give us one. Yeah. So that was a good one, but just for us to keep us, you know.
Yeah, sure. I will. Yeah.
You know, yeah, you know what I mean, huh?
Yes, I will do that.
Kind of, you know, like just practice out of nowhere. Huh? We need to have some questions, you know, around, you know, all these, you know, things that we are learning, so that we just keep ourselves busy and, you know, and practice, right?
That is noted. I shall do that. I shall do that. Thank you very much for that wonderful, wonderful contribution. All right, so colleagues, if there are no questions, we don't want to overdo it because we have a 3-hour session tomorrow. So I'll see you tomorrow at 17:30. Try as much as possible to be early. I transitioned to a different class on Mondays, 17 hours class, so I may just be 15 minutes late at the most. So I'll see you tomorrow. Let's just say 17:45 tomorrow. Thank you very much. Good day.